We are up to Thursday, August 4th, 16th day of the semester for Math 1342 Statistics. Today is the review day for Test 4. And the test has 10 multiple choice, 10 free response. If I go in here to assignments, Test 4, Chapter 8, 9. So this will be available August 4th at 12 a.m. all the way to August 5th at 11:59 p.m. The final exam is next week, August 10th or 11th, 2-day window for that too. So these are all created and all set to go now. There's 15 total questions plus an optional bonus and trivia. The first 10 are multiple choice, 5 points each. The last 5 are free response, 10 points each. And you can earn partial credit on the free response, so be sure to fill in each part. You're going to be doing the 4 steps each time. You get 90 minutes in one attempt only. You can use blank scratch paper, any calculator, and pages 1 and 7. You won't need page 8. That's only for chapter 6. So pages 1 and 7 are the formula pages. So the multiple choice, the 10 multiple choice questions, they're very similar to the 10 on the quiz. So use your quiz and study that. Quiz-like. 10 similar questions. If you missed any, now you got a chance to get them right the second time. The 5 free response, these are 5 of the 7 types of hypothesis tests. You got your z-test, your t-test, your 1-prop z-test, the 2-sample z, the 2-sample t, and the 2-prop z-test. And then you got your before and after for those where you just do a regular t-test because the samples are dependent. When you go to stat and test in a graphing calculator, the first 6 on there, plus the before and after kind. So you need to know all 7, but otherwise it would take 2 hours to do all 7 of them, so I can shorten it a little by making it just 5 of the 7. But you have to know all 7 because you don't know which 2 are not going to be there. But I'll kind of give you a little bit of hint on that while we do the review. Okay, so then next week we, on Monday, cover a little bit of chapter 10 and 11 because there's a little bit of that on the final. Tuesday is our review day. There's officially no class on Wednesday. If this was an in-person or a live class, it wouldn't meet on Wednesday, and then the exam is Thursday, but you guys get the 2-day window as usual, so you can take it either Wednesday or Thursday. And that way you can use Wednesday as a extra study day if you want to. Okay, so inside Connect Math, we're on review 4, chapters 8 and 9. 3 students have already tried this and averaged 97%, so you can do it more than once, and the more the better. The review's only got 10 questions. Let me see what the non-free response would be. Okay, this would be like a multiple choice questions like this one. So we had this on the quiz, and it's on the test again, and it's in the review. Classify a hypothesis test as a type 1, type 2, or a correct decision. So the whole essence of this comes down to this paragraph at the bottom. We need to be told if the null was rejected or not rejected. You know, step 3 of every problem, you either reject the null or you do not reject the null. So they have to tell me that somebody, in this case, rejected the null. And then this is the part we normally don't know, but we don't know if we're making a right decision by doing that. So what if in fact the average scores of students has changed? If the reality is that it's changed, that means the one where the not equal to is actually true. Or they could just say, like the quiz said, if in fact the alternative is true. So you want to take those 2 things that are given to you in the problem. in this problem, I was told the null was rejected. It wasn't a case where it was not rejected. They rejected the null. And one way or another, I was basically told the alternative was the one that is true. The alternative is actually true. Nobody in reality would really know that, but that's the reality. So if you like put a bad guy in jail, you put an innocent person in jail, they know that they're innocent, but they're the only ones that know that. So they know the reality is they're innocent, but they're getting punished needlessly. So that's one of these two types of errors. So this could say reject or do not reject, and this could say H1 is true, or H0 is true, or H1 is false, or H0 is false. They could tell me any of those four things. So this is the combination I happen to get. So then you do routine for fun, and you capitalize all the consonants, lowercase all the vowels. Routine, separate it, for fun. Routine is for type 1 error. For fun is for type 2. Type 1 error, its definition is literally reject a true null. If I were to reject a true null, that would be a type 1 error. But I didn't do that here. I rejected a true H1 actually. So that means I did not reject a true null. The null is not true. The alternative is actually true, because they said, what if the reality is it has changed? So if this had said H0 is true, H0 is true, then you're rejecting a true null. That would be type 1 error. But this is not type 1 error because I didn't have that H0 is true. So I checked, did this happen? No. And I'm going to check, did this one happen? Did we fail or not reject, fail to reject or not reject a false null? Well, it is true that the null is false, because if H1 is the one that's true, then H0 has to be the one that's false, and vice versa. If they come out and tell you that H1 is false, then you know H0 is true, because that's exactly what we do, is we set it up so there's always one true and one false. So this is actually true that the null is false. There is a false null because the alternative is true. But we didn't fail to reject it. So if they would have said fail to reject when H1 is true, then you'd be making a type 2 error, because then you'd really have failed to reject a false null. So we didn't have a type 1 error. We didn't have a type 2 error. Therefore, it's one of the two versions of a correct decision. And luckily here you don't need to know the difference between the two. But the two correct decisions are, if the null is actually true, then you should not reject it. You wouldn't want to put somebody in jail who's innocent. So if the null is actually true, you shouldn't be rejecting it. If the null is actually false, then you should be rejecting it. So those are two different correct decisions, but they just lumped them together here. So we have one of those two correct decisions, because we didn't have a type 1 error, we didn't have a type 2 error. So this was a multiple choice question in the homework. It was on the quiz. Here it is in the review, and it's one of the multiple choice questions on the test as well. So we got that one out of the way. 5, this is the type we skipped in chapter 8, problems 19 and 20 in chapter 8, so you can skip it here on the chapter 8 and 9 review. So skip number 9, and I'll give you credit for that. You'll get 10 extra points added at the end. 9-1, 9-2, 9-3. Okay, and then this real quick, this isn't really on the test at all, but just so you can get credit for your homework. This is that one about the P bar and the Q bar, where you're kind of pooling these together. So we asked 74 people in the first population a yes/no question. 24 said yes. We asked 75 people in a second sample, and 26 said yes. P bar is literally adding the x's and adding the n's and dividing them. So the x's are 24 plus 26, which is 50. The n's are 74 plus 75, which is 149. So it's literally 50 divided by 149. 50 divided by 149 is 0.33557. They say round to 3 decimals, so 336 if you add 1 to that 5. P bar is 336. And then 1 minus 336 is 664. So, whoops. So this is where I did 1 minus 336, but it was 24 plus 26 is 50. 74 plus 75, whoops. 74 plus 75 was, whoops, keep doing that. 74 plus 75, you'd think that would be easy to type it. 149. So 50 divided by 149 is 3355 or 336. So P bar is 336. 1 minus 336 is how you get Q bar 664. So what this represents is it's a pooled amount. It's kind of like a weighted average. If the first one, say the first one is females and the second one's males, each one has its own proportion. If you do 24 divided by 74, then you're saying 32% of females said yes. If you do 26 divided by 75, then you got 35% of males are saying yes. And then the 336 is kind of an average of those two. And it's not a straight average unless the sample sizes are equal. And here they're actually really, really close, but sometimes they're off quite a bit. So if one has a higher sample than the other, then that'll make that answer closer to theirs. So 32 and 35 were the two sample proportions, and we're halfway in between roughly of 336. So 9 should be easy. 4 is a little challenging. Make sure you practice that, and that one is a multiple choice question. 9's not on the test, but you can get an easy 10 points on the review for that. And you get to skip number 5. So there's 7 problems left. 1 through 3, 6 through 8, and 10. 7 problems left. Those are exactly the 7 you need to know for the 5 potential free responses. And just study your quiz if you want to get the multiple choice right. So we're going to now spend the rest of this video going over the 7 types of questions that could be the 5 free responses. An obstetrician read that a newborn baby loses on average 7 ounces in the first 2 days of his or her life. So that could be a claim. The claim could be that the mean is 7, average is 7. But Connect Math, they like to switch it in this next sentence often. He feels in the hospital where he works, the average weight loss of a baby is less than 7. So that's going to supersede the first sentence. Less than has to go in the alternative because it doesn't have an equal to attach to it. And if you get just greater than or just less than, that's a one-tailed test. But this one's a claim because they switched it right there. He feels, he claims. We know in Connect Math the null is always equal no matter what, so you could have filled that one in right away, but I like to fill the claim in first. Then I know this one's not the claim. And if you go R, S alphabetically, since the claim's in the alternative, we're going to try to support it at the very end, regardless of how it turns out when we do the calculation. Okay, so he feels it's less than 7. A random sample of 31 babies, there's N, has a mean weight loss of 6.4. That's X bar. It's coming from the sample. If they would have said with a standard deviation or and a standard deviation, then that would have been S. But instead they did a separate sentence and said the population standard deviation is 1.6. So that's sigma, that's population standard deviation. Is there enough evidence at alpha 0.10 to support his claim? See, they even said that. Can you support his claim? And I already said that's what we're going to say at the end. So they put this in the paragraph sometimes, not every time, but maybe about half the time. So you'll do your step 1 on the test. What happened on the test is I wrote the paragraph out. It's all free response. And then it literally says step 1, tell me your null and alternative. Now you won't be able to put it right where these blanks are, but that will remind you what the steps are. So this is where mu equals 7, which is not the claim. Mu less than 7 is the claim. RS alphabetically. You don't have to do this on the test, but maybe on your scratch paper. This is why I'm going to try to support the claim at the end. If the claim was in the null, I would try to reject the claim at the end. So on the test, it already says step 1 like this, and then that will remind you, okay, you should do that first. Then it says step 2, p-value. So here's where you got to decide which test you're doing. So we had a random sample of 31. Random sample of 31. This random sample had an average of, so that's x bar sample mean, since it's coming from the random sample, a mean weight loss of 6.4. But then it said population standard deviation. Population standard deviation was 1.6. And I'm given an alpha of 0.10. So I'm going to have to hope the p-value is less than that if I want to reject the null. Because they gave me sigma and there's only one sample here, this is a z-test. It's about averages, but there's only one sample. And sigma's known, that's a z-test. So in the graphing calculator, you go to stat test and you choose number 1, the z-test. And you can set your calculator to stats because the only data problem is the before and after. And then they want mu 0 first, so that's right here, mu 0. Mu 0 is 7, so put 7 in first. They want sigma second, so that's 1.6. X bar is third, 6.4. N goes next, 31. And then you have to tell your calculator, is the mean right here, is this mean not equal to the 1 in the null hypothesis, less than the 1 in the null hypothesis, or greater than that value? And in other words, they want this right here. That's less than, which is this middle one. That tells the calculator which alternative you had. And then you hit calculate. I'm doing a backup video here on a phone because I'm starting to have issues with the recording device here. I am recording right there. It's at 18 minutes and 45 seconds, but they're not, when I record them in this program now lately, they haven't been showing up in the media gallery. So I might need to share this video another way if it doesn't work today. So calculate, and you get a z-score of negative 2.08. You don't need that unless you want to do critical values, but I look at it sometimes and say, okay, that's starting to get in the unusual range. If it's a 0 or a 1, positive or negative, then that's usually not so unusual. If it's a -2, a -3, or even worse, then you start getting really low p-values. So the p-value is sort of low, 0.184. And then there's a 0 after that, so we don't have to add one. So on the test, you'll just say my step 2 is 0.184. Whoops, I didn't check this answer yet. 0.184. Okay, then step 3 on the test says Whoops, I thought I clicked it. Step 3 says give a generic conclusion. Do it just like the homework. Generic conclusion. So this is where you want to compare P to alpha. Whoops. That wrong. Okay. P to alpha. P was 0.184, the p-value, the probability. Alpha was given to me as 0.10. Don't say 184 is greater than 10. Some people do. 184 is less than 1,000. So we reject the null hypothesis. This is where you're rejecting the null. But if it turns out the null actually is true, then you're making a type 1 error actually. See, it seems like the null is not true because we did get 6.4 in the sample. That seems to be less than 7. But how less than 7 does it have to get to be really less than 7? That's what the p-value is telling you. So the p-value is saying there's only about a 1% chance that if truly the null is true, if truly these average weights are 7, there's only a 1% chance we would get 6.4 in a sample. So since that's less than the given alpha, that's when we reach the unusual probability level. So we can either believe something unusual just occurred to us, or we can believe that the reason we're getting such a low probability is probably the mean's not 7, it is probably something less than 7. And that's why our sample mean is lower, is because the sample mean's probably close to the real mean. And the real mean's probably not 7 because of that. It's not a guarantee that we're right, but we got like a 99% chance of being right here. But there are those 1% that slip through the cracks, and then those are the ones of the innocent people in jail, unfortunately. So step 3 was the generic conclusion, and then step 4 is the specific one, although the homework does a lot of it for you, and you can just do it like the homework, so it doesn't have to be different than the homework. But specific conclusion, so this is where you'd say since step 3 was reject the null, step 4 then would be there is enough evidence to support the claim. That's all you have to do on the test. So every one of your step 3s is either going to be reject the null or do not reject the null. And every step 4 will be is or is not enough evidence to support or to reject the claim. There's 4 possible endings to that. And every one is done by the same rules no matter what type of test you're doing. So this one was reject the null because the p-value was low, so the null had to go. And that means there is enough evidence to support the claim. But this is why they call it the specific conclusion, is because they actually add stuff from the actual problem. There is enough evidence to support the claim that the average weight loss of a newborn baby is less than 7. There's enough evidence to support that. It's not a guarantee that it's true, but it's pretty strong evidence that it is. But we could be making a type 1 error if we reject the true null. If the null turns out to be true and we reject it, that's a type 1 error, which does happen on occasion. And with a high alpha, the higher alpha gets, the more likely you are to make a type 1 error. Okay, so number 2, very similar. Now we have a survey of 15 large U.S. cities, so that's N. They have an average commute time of 25.4, so that's X bar since it came from the sample. And then a Chamber of Commerce executive feels that the commute in his city is less and wants to publicize this. So less, there it is again, less. That's the claim. He thinks it's less than this 25.4. So that's one-tailed again. We know the null is going to be equal to. And usually in Connect Math, it's not the claim, but on the test, I tried to mix it up, half and half. Sometimes the claim's in the null, sometimes it's in the alternate. We did see 3 in the homework where it landed in the null. He randomly selects 26. Okay, that's weird that we got two samples here. Okay, so he randomly selects 26. That's his random sample. He finds the average is 23.4 with a standard deviation of 5.3. See how this standard deviation is with the sample information. So this actually, I guess this first sentence is just for comparison. This was probably done previously. And this is another thing that can happen, is sometimes something was done previously and this is what it used to be. Think of like gas prices. Those change a lot over time. So this is what it used to be, and now over time things can change. Things aren't always set in stone. So people will quote things from the past until a new study comes along to prove it wrong. So that's what this guy, this executive or this woman, he or she, it doesn't say if it's a he or she, they think that it's not this anymore, is another way of thinking about this. So when they suspect that this isn't right, then they go out and do it does say he right here. So he goes out and selects his own random sample and gets a sample mean, in this case, a sample standard deviation. At alpha 0.02, is he correct? So that's why normally they don't have this extra sample size in the problem. That was a little weird there. But actually, it's not really a sample because we're considering this to be the population mean. We said mu was 25.4, not x bar. Okay, so just ignore that 15. But what's different on number 2 compared to 1 is when they mention where he's taken a random sample, there's always a mean in that sentence, but then it says with a standard deviation. So it doesn't say population or sample, but this is definitely sample because it's with all the sample information. So number 2, we got our step 1. The null was equal to 25.4. Mu is equal to 25.4. That's not the claim. The alternative, I should make that a better looking 0. There we go. The alternative was less than for the second time in a row. And for the second time in a row, it was the claim too. RS, we're going to try to support this claim at the end. P-value. So this time I'm told that the sample size is 26. The sample size of 26 has a mean of 23.4, which does seem to be quite a bit less than 25.4. So maybe we're going to reject this one too. But then the key difference is with a standard deviation, that's S, 5.3. So because it's S, we're going to do a t-test. We're still doing averages. There's only one sample. There really should only be one sample. That first one might be a little misleading. But the first sample didn't include all the information. It was there, I guess, because they got it from somewhere else is why they said that. And then we have alpha of 0.02 this time. So they'll usually change that from problem to problem. Okay, so t-test. Stat test, go down to number 2, t-test. Keep yourself on stats and not data. Mu 0 is right here. Mu 0 is the 25.4. They want X bar right away next, 23.4. SX, remember that's the same thing as S, 5.3. N is 26. And then we got to find this right there, but it's less than for the second time in a row. So my calculator is already on less than. I don't need to change it. And then we can hit calculate. The t-score is only negative 0.19. That's real close to 0. So the p-value is really high this time. 42448. So I'll bump that up to 4.5. See, here we thought that 23.4 seemed like it was far from 25.4, but this is saying that's really not that far away. This is saying there's a 42% chance of seeing that happen. 42% chance that if the null is actually true, that you would see as low as 23.4 in a sample. That could happen. If there was a 40% chance of rain and it rained, you wouldn't be shocked. How did that possibly happen? But if the probability is 1% for rain and then it rains, then you're probably wondering how the heck did that happen? So 0.4245, and this p-value is greater than any alpha they would give you, but it's a lot greater than the 0.02 they gave me. And this is good that we're getting a little variety in the endings here, because Connect Math will sometimes do they did the less than and the claim in the same spot for the second time in a row. But at least this time this is greater than, so we do not reject the null because the p-value is not low, it's not less. So our step 4 then would be not enough evidence, because step 3 was do not reject the null. Not enough evidence, but we're still going to say to support the claim. We were trying to support the claim that it was less, but even though our sample was less, it wasn't less enough. So that's the key thing, is you don't want to just look at the sample and say, yeah, that seems like that is pretty less. Here's a good example that shows that would have been misleading to do it that way. So I need 4245 for step 2, and then these are both the nots, and then support at the end, which we knew was going to happen after we finished step 1. So p-value is 4245. Okay, maybe I did type something in wrong then. Let me double check. I could have had a typo and not even realized it. 25.4. Oh yeah, I do have a typo. I put 53 for S, not 5.3. So maybe that is significant after all. But at least you got to see the opposite ending that could happen. And it's still going to have the same ending, just the p-value is different. So yeah, if you have a typo, that's the one downside. You'll never know it's wrong because you don't get the advantage of this where it tells me I made a mistake. So 0.03289, so I'll bump that up to 29. So I would have missed that if I was taking the test. That was 2 points for that part. I would have lost 2 points. So watch out for careless typos. And then, but that's still greater than 0.02, because if you add 2 zeros to that, that's 0200. And this is 329. 329 is greater than 200. So we're still going to say do not reject the null. And there's not enough evidence to support the claim, although they did that part for you here. But you'll have to do that on the test. And keep this in mind, I said this already, that there's partial credit on these free response questions. If you mess up your p-value like I just did, and it causes the step 3 and 4 to be the wrong answer compared to the answer key, you'll still get full credit if you do it right from your p-value. In fact, if your p-value is saying you should not reject and the answer key says reject because the actual p-value was actually less than alpha, and then if somebody says reject in step 3, they'll lose points, even though that's what the answer key says, because they shouldn't be saying that if their p-value is greater than alpha. So just keep, I'm going to grade your part 3 and part 4 completely based on what you put in the p-value. And if yours is wrong, then I got to throw the answer key away and grade what you have there. Is your p-value greater or less than the given alpha? It doesn't matter what the answer key has at that point anymore. You lose 2 points for getting this wrong, but then you can get the last 6 points. Or is it 4? 2, 4, 6. It's 2 point. There's 4 parts here, so 2 times 4 is 8. So there's 2 extra points, and this can definitely be worth more than 2 points because you got to get the variable right, the inequalities in the number, and which one's the claim. So I think part 1's worth 4 points. Then each of these is worth 2, and that's 10 total points. So if you get the p-value wrong, you don't lose 6 points instantly. You could in general, but you won't in this test because I don't grade it that way. Some teachers do, but some teachers just grade what's on the answer key. And even if you miss part 2 and that causes you to miss 3 and 4, they might not give you credit for that. But I grade your part 3 and 4 based on what you have in part 2. And that way, if you make a mistake, it doesn't cost you 6 points, it only costs you 2. If you know how to do step 3 and 4, you can get them right in every problem. In fact, if you get a problem you don't even know how to do it, you could make up your own p-value and just finish the problem from there and get at least those last 4 points. So 1 and 2 are so similar, the only difference between them is whether you have S or sigma. That's literally the only difference. S is t-test, and sigma is z-test. Otherwise, the problems are almost identical. So if you get one of these right, you would probably get them both right, other than minor mistakes like what I did or some kind of typo or brain cramp. But if I put all these on the test, not only would it take 2 hours, but students either get both of these mostly right or they get both of them mostly wrong. So why double punish somebody that doesn't know what they're doing? So I can shorten it, and that way it won't take you more than an hour and a half. So there's either going to be a Z or a T test, but not both. So if you know both, you should be able to handle either one, but that way you don't have to, each one of these problems could take 10 minutes to do or more. So that'll save a good 10 to 15 minutes by eliminating one of those two. And then we're going to eliminate either the 2 sample Z or the 2 sample T. And that'll save another 10 or 15 minutes. So instead of a 2-hour test, it's an hour and a half. Okay, so that's what the next two should be. There should be a, or maybe we're going to do the 1 prop. Yeah, we have this first. So this is the 1 prop z-test because now we've switched to proportions. 14% of men said they used exercise to reduce stress. But maybe somebody doesn't believe that that's true anymore. So they take a random sample of 118 men. 9, they ask them yes or no. Does that help you relieve stress? 9 said yes. Alpha is 0.05. So this is a good one because the very first sentence states that it's 14%. That it is 14%. Not that it's higher, lower, too high, too low, at least, at most. There's no direction to that. It's just a very generic 14%. And they don't have the usual next sentence where they say he feels or he believes or he claims. So they're not changing it. This is how more problems normally go. So this is why you can get the claim literally in the null hypothesis. This one has a claim in the null because it's just 14%. So if we want to say this is wrong, the opposite of this would be not equal to. That's not the claim here, but if we try to reject the claim, then we're trying to prove this one right. And because that's not equal to, it's two-tailed. So now we get to say to reject the claim at the end since we have another one with the claims in the null. So number 3, it should be real obvious when you've switched to proportions. There's no standard deviation. There's no average. So number 3, P equals 14%. Make sure you change that to a decimal, 0.14. And then the alternative is P is not equal to 14. 0.14. And this one's the claim for the first time today. And for a rare time for Connect Math. So RS alphabetically, we're going to try to reject the claim since it's in the null this time. That's going to be the end of step 4 no matter what. Okay, to get my p-value, I have a random sample of 118 men and 9 said yes. That's N and that's X. X is the number of yeses to a yes-no question. There is no X bar, there is no S, there is no sigma. That's because we're doing proportions and not means. Alpha is 0.05. So this is the 1 prop z-test, number 5 in the calculator. You're definitely going to get one of these on the test. Both the 1 prop and the 2 prop z-tests are on the test. That's 5 and 6 in the calculator. And then you get either number 1 or number 2, z-test or t-test, and then you're going to get either number 3 or number 4, 2 samples, z or t. So this one's pretty easy to fill into the calculator because you go to stat test number 5. There is no input at the top for data or stats. It only needs 3 numbers, and then you choose your alternative hypothesis. P0's right there, but you have to have it as a decimal, 0.14. If you put 14 for 14%, you'll get an error. The calculator needs X first and N second, but it's often backwards in the paragraph. So the N was the sample size first, 118, and X was 9, the number of yeses. So we need to put the 9 first and the 118 second. And then, as always, you need to tell the calculator, is your alternative hypothesis not equal to, or is it less than, or is it greater than? All you have to do is look up here. Ours is not equal to. That's the obvious one. But my calculator is currently set for less than because that's what I did lastly in the other 2 problems. So I need to click enter while it's flashing on not equal to. Calculate. P-value is, if I don't have any typos this time, 0460. 0460. Oh, 0460. There we go. So now we got to do the same step 3 and 4 of every problem. You can get 4 points on every problem just by knowing this really well. Unfortunately, some people miss these 4 points on every problem. They haven't practiced enough or done their homework or even watched any of the videos. So P in alpha, P is 0460. Alpha is 0.05. And add 2 zeros for a fair comparison. 460 compared to 500. 460 is less than 500. So we reject the null hypothesis because the p-value is low. The p-value is less, the null must go. And if you reject the null, then there is enough evidence. You either put not for both of them or not for neither of them. There is enough evidence to reject the claim, not support the claim. To reject the claim. We can reject this claim and say it's not equal to 14% anymore. Maybe it used to be, but maybe times have changed with COVID and all the political strife and the wars around the world. So apparently the exercise is either not helping or maybe it's helping more to relieve stress. We don't really care if it's because it's more or less, but we just proved that it's not the same as it used to be. It's not 14% anymore. At least that's what our evidence is telling us. But we could be making a type 1 error if we do that. But it's more likely it's a correct decision. So reject the null because the p-value was low, so the null must go. And that means there is enough evidence to reject the claim, which they said they did it for you again, but there is enough evidence to reject the claim. Notice it doesn't say support the claim here. That is correct because it was in the null hypothesis. So problems 1, 2, and 3, those are the 3 chapter 8 problems. Those are the 3 chapter 8 types of tests. And you have to know either 1 or 2, and then definitely 3. 4 was is in the multiple choice section. 5 you're skipping. Okay, so we have 6, 7, 8, and 10. 6 and 7, you're going to have one or the other of these too. These two are very similar to each other. A researcher wishes to see if there is a difference in the manual dexterity of athletes and band members. 2 random samples of 30. See, it's 2 samples. That's immediately chapter 9 right there. We've got two different populations, band and athletes. So that's why this is a chapter 9 problem. It's a two sample problem. The mean of the athletes was 85. This is about means, so it can't be a proportion problem. The mean of the band was 87. The population standard deviation for the test is 7.7. Population standard deviation. Use mu1 for the athletes. So we got to put the athletes first. Alpha's 0.10. So we're going to put the athletes first and the band second. They each have a random sample of 30, although they could have separate random samples too. Or not separate, but they are separate, but they could be different sized. They could say 30 athletes and 40 band members were randomly selected. I'm assuming these are independent samples, that they don't affect each other, because usually the band and the athletes practice separately, so that's a good assumption that these are independent. Two random samples of 30 from each group are taken. The mean of the athletes was 85. The mean of the band was 87. So that's X bar 1 was 85. X bar 2 was 87. So that's a little bit of a difference, but maybe not a significant difference. The population standard deviation for the test is 7.7. In other words, just use the same one for both of them. But sometimes they tell them to you separately. So it could have said that the population standard deviation for the athletes is 7.7. The population standard deviation for the band is 8.7. It could have easily been like that. And then we have an alpha of 0.10. So we need to get less than that if we want to reject the null. If we're greater than that, we don't reject the null. So the real big difference here in chapter 9 is how you do step 1. The rest is pretty similar. So the key thing is you never put any numbers here. Now they did say a researcher wishes to see if there is a difference. And even in the question, is there a significant difference? That's the claim. The claim is that these two populations are different from each other. They're not equal if they're different. So mu1 is not equal to mu2. That's the claim. And the null is always mu1 equals mu2 when you have two means going on. And then this is two-tailed because we have not equal to. So remember how this is kind of backwards. They say if there is a difference, is sounds like equals, but is a difference, then the claim's actually not equal to. If they put a researcher wishes to see if there is no difference means they're the same. And then that would be the claim in the null, actually, that the equals would be the claim. So difference means they're different. No difference means they're the same. Because they gave me population standard deviation, then I'm running a two-sample z-test. And it's just like the one-sample z-test, except you have twice as much information to put in. Okay, so stat test number 3, two-sample z-test. Input will just be stats. You won't need data except for the before and after, which is a unique problem that's obvious when you have that. So they want sigma 1 first, 7.7. Sigma 2, 7.7. They put the sigmas first and second to emphasize you have to know sigma to do z. X bar 1 is 85. N1 is 30. X bar 2 is 87. N2 is also 30. And then I just need to know what my alternative was. Mine was not equal to, so I can just leave it where I have it already and hit calculate. So I just got a p-value, p-value of 31443, which if we round to 4 places is 3144. 3144. So now the rest should be easy. Compare the P to alpha. 3144 compared to 0.10, which is 0.1000. That's greater. So we do not reject the null because the p-value is not less. Do not reject the null. That's saying that these two sample means are not really all that different. They're slightly different, but not significantly different. Somebody might say, oh, the band is better because their average is higher, but it's only a slight difference. And these are just one sample in one moment in time. If I did it again tomorrow, I might get completely different answers. So you need to have a significant difference in those, which will make the p-value get really, really low in order to really say the band is better. So then, since we did not reject the null, then there's not enough evidence and we're back to the good old support the claim because they had it in the alternative again. To support the claim. So this is how you should do it on your test. You just fill these things in, put down your p-value, write out your step 3, write out your step 4, and you can just write this is good enough, and then do your null and alternative. So not enough, no, I'm on the wrong part. Do not reject the null hypothesis, or you can just say do not reject the null, that's fine. There is not enough evidence to support the claim because it was in the alternative. And you can always go back and check that at the end. So that was a 2-sample z-test, pretty similar to a 1-sample z-test, just you had 2 things going on at once. The biggest difference is here, you don't put any numbers right here. In chapter 8, it was mu equals a number and mu is not equal to a number. That's really the only difference here. So this problem is very similar to the last one. The only difference is these standard deviations are not population standard deviations, they're coming from samples. They did a random sample of 15 houses in each city and obtained the following statistics. So this is all sample information down here. It doesn't say it's sample standard deviation, but if it comes from a sample, it's sample standard deviation. So we have S's, we don't have sigmas, we have to do a T now instead of a Z. At alpha 0.01, can it be concluded the houses in Whiting are older? Now just be careful that order is the same as the question. See how Whiting is first, Franklin is second. So if Whiting are older, older is greater than, but only if Whiting is actually listed first like it is here. So then sometimes they'll say, are houses in Franklin younger? And if they said that, you would still put a greater than, because if Franklin is younger than Whiting, then Whiting is greater than Franklin, older. So greater than is the claim, and that has to go in the alternative because it doesn't have an equal to. And therefore the null will be just equal to as always. One-tailed because this is greater than. So each sample is 15. N1 and N2 are both 15. X bar 1 is this first mean. X bar 2 is the second mean. S1 is the first standard deviation. S2 is the second standard deviation. And we're given an alpha of 0.01. So I'm going to go to stat tests number 4. 2-sample t-test because we don't know sigma. We have our sample standard deviations. Keep yourself on stats for input. They want X bar 1 first, that's 63.5. S1 or SX1, that's 5.4. Both sample sizes are 15, so N1's 15. X bar 2 is 57.1. Now in the sample it looks like the Whiting houses are older in average age. That maybe is a significant difference right there. SX2 is 3.9. N2 is also 15 because it's at a random sample of 15 in each city. And then our alternative was greater than. So that's the one on the far right. You got not equal to first always. Less than's in the middle, and greater than's the far right. So you got to go to the far right and click enter. And then two sample t-tests. This is the only one that has one extra thing. Pooled, no or yes. And if you read in the paragraph at the very end, assume the variables are normal and the variances are unequal. The only kind of problem that mentions variances equal or unequal is a two sample t. So if you see that in the paragraph, that can be a giveaway. Oh, this better be a two sample t-test. Variances are unequal, then you say no to pooled. If it says assume the variances are equal, then you would say yes to pooled actually. This one says unequal, so I'm going to say no to pooled. And notice they did say use mu1 for Whiting. Whiting is the first one. So that way they could say, is Franklin younger? And then you would still put a greater than here because Whiting is the first one. So I need to click no to pooled and then hit calculate. The p-value is, now be careful about this. I think I got one of these by accident one time, or maybe it was actually legitimate. My p-value says 4.9345, and somebody's going to see this on their test and go, okay, 4.9 is the p-value. That's greater than alpha, whatever alpha is, 0.01. So then they're going to say, do not reject the null, not enough evidence to support the claim. And that's actually all wrong because you're not looking far enough across your calculator screen. 4.93, probability can't be 4.9, that's impossible. Probability can't be bigger than 1. 4.9, nope, look all the way at the end, there's an e negative 4 there. This is not 4.9. This is 4.9 e negative 4. The reason this is happening is this is a significant difference. The houses in Whiting are significantly older than Franklin, so much so that we're getting an extremely low probability. It's so low the calculator is switching it to scientific notation. This is 4.9 times 10 to the negative 4th. So you got to move your decimal over once to get past the 4, 2, 3, 4 times. So you actually get 3 zeros because of that. The p-value is not 4.9, it's 0.00049. On and on and on, but we're going to round to 4 places, so 0.005. That's how low it is. It's extremely low. It's nowhere close to 4.9. It can't even be bigger than 1, first of all. And it completely changes your step 3 and 4 if you don't get this right. 0.005. This is way less than any alpha they would give us. They actually gave me the lowest possible alpha, and I'm still way less than that. 0.005 is less than 0.0100. 5 is less than 100. Reject the null. It's not, if you put this by accident, you're going to think do not reject the null. You're getting completely the wrong answer. You're telling these people that you can live in either neighborhood or either city because the houses are the same age, but no, the first cities has older houses. So if somebody's looking for a younger house, they should go to Franklin, but you're giving them the wrong advice then. Reject the null. There is enough evidence. There is enough evidence to support the claim that the houses in Whiting are older. And if you like a newer house, you should go to the other city. Now, maybe you like old and classic, maybe, or you want to buy one and turn it into a museum or something. So then you should go to the older ones. But there is a significant difference here. You would never get this much of a difference in sample averages in just a random sample, because the probability of seeing that is 0.005. It's like better chance to win the lottery than see that happen. So reject the null. there is enough evidence to support the claim. Houses in Whiting are older. We agree with the claim. So you're going to get one or the other of those, and what I usually tell students is, if you think 1 or 2, you're going to get one of those. If you think you have a z-test for the chapter 8, then this will probably be t. Or if you think 1 or 2 is the t-test, then this should be the 2 sample z. Because I like to see you do 1 z and 1 t that way. If you think they're both z or both t, you're probably doing something wrong. Okay, so we got 2 things left. Let me do 10 first. This one's pretty easy. This is the, is there a difference in proportion? So we switched to proportions. But there's 2 of them. There's airline A and there's airline B. We have 2 N's and then we have 2 X's, the number of yeses. So they had 302 flights in airline A, and were you on time? 214 said yes. Well, maybe this was before they have all the airline problems right now that they're having. Airline B, 359, they asked, and 289 said yes, we're on time. Is there a difference in their proportions? So that's saying that they're different from each other. But it's P's, not mu's. P1 is not equal to P2. That's the claim. So we want to see if one airline's better than the other by doing that. The null just says, no, it doesn't matter which airline you pick. They're both equally good or equally bad if you want to have a negative point of view. So you're going to be stuck waiting for your flight with either one of them equally. This is a two-tailed test. That's really the only difference compared to our last 2 problems, is that you put P's here instead of mu's. And then it's really easy to fill this in the calculator. Stat test number 6, 2 prop z-test. All you need is x1, n1, x2, n2, and tell it what your alternative is. And as long as you know which one of these is which, it's easy. x1 is the 214, the number of yeses to the first population. n1 is the first sample size, 302. x2 is the second number of yeses, 289. n2 is 359, the second sample size. And I had not equal to again in the alternative. So I got to go back to not equal to because I'm currently on greater than. And then select it and press calculate. So I did get a low p-value, but it's not scientific notation at least. 0.00379. So if you round that to 4, you're going to have to add 1 to your 7 and make it an 8. 0.038. That's pretty low. That's less than 1%. That's less than any alpha they would give you. They gave me the highest possible alpha, 0.10, which is actually 0.1000. 0.038 is less than 1,000. So my p-value is less, my p-value is low, the null must go, so reject the null. And if I reject the null, there is enough evidence. And like they usually say, to support the claim, because they like to put the claim in the alternate. But at least we had 1 today that was in the null, and we had 3 in the homework. I searched and searched and searched just to try to get just a little practice on those, because if you just randomly pick some homework problems, I did that one semester, and every single one of them was in the alternative, and the students thought, oh, it never goes there. And it was the first time I used Connect Math. I was like, boy, they don't really mix this up very well. Okay, last thing is number 8. This should be obvious when you're doing this, the before and afters. So what happens here is you always use mu d. That stands for the mean difference. The mean difference equals 0 no matter what in the null, and that's usually not the claim for them at least. The tricky one is the alternative, where you say the mean difference is either less than, greater than, or not equal to 0. And your best bet to get that right is look what's happening with the numbers. Are they going down or up for the most part? Each one of here's one that's going up, but the rest of them are all, oh, here's another one, but the majority of them are going down. I'm going down from 65 to 58, down from 44 to 41. So if you subtracted that, would you be getting positives or negatives? 65 minus 58 is positive 7. 44 minus 41 is positive 3. 48 minus 45 is positive 3. You're getting positives because the mean difference is greater than 0. Greater than 0 is a positive. But what the wording of it's going to be, it's going to say something like that they're losing weight. Well, let me find the claim here. 8 dogs were randomly selected. Okay. Can it be concluded the dogs lost weight? So they're getting smaller in weight. So it sounds like you should put less than here. But what's happening is they used to weigh more, and now afterwards they weigh less, so their weight went down. And if mean difference, if I subtract their before minus their after, that's producing a positive answer. If the mean difference is positive, that's good. That means they lost weight, which is what the program was about. And that's one-tailed. So if we're trying to get these dogs to lose weight, then we'll only be successful if the subtractions, if the differences are positive. Because you only get a positive when the first number is bigger and the second number is smaller. Now, it doesn't mean every single dog loses weight or every single dog loses a lot of weight. It's about the mean difference. So just as long as it's on average is all we care about. It's okay if one dog actually gained weight. So this guy was probably just sitting in his beanbag or whatever on the ground and just chilling out too much and gained weight. The diet didn't help that dog. Okay, so to do this in the calculator, it's not one of your stat and test directly, but we can do one of them. But in order to do it, you have to trick your calculator a little bit. So you go to Stat and Edit. Clear out. You only have to clear out List 1 and List 2. Put the befores in List 1. I just go straight across like I'm reading a book. Now go to L2 and put the afters in. And of course, I'm doing this fast, so watch out for typos or you'll get all the answers wrong. And then you have to travel with your arrows, move over to L3. It's okay if there's already numbers there. Go all the way up to the top. Don't stop there. All the way to the top. There. Now the cursor is highlighting L3. When that's happening, you press second L1 minus second L2. Enter, and it does all of them for you. So there, 7, 3, 3 are the first three numbers. That's what I did by hand here. 65 minus 58 is 7. 44 minus 41 is 3. 48 minus 45 is 3. All of them are positive except those two negatives. Now, the fact that there's some negatives is probably going to mean we're not going to reject the null. But if they all were significant positive numbers, then you probably will reject the null. But we don't really care about that at this point. So I've got all the differences. All the differences are in L3. So this is a dependent sample. These are the same dogs both times. So you get this big dog here that weighed the most of any dog. He or she's got a lot to lose. They can show a significant difference. But the real tiny dogs, they don't really lose that much. So because depending how you are before can affect how easy it is to affect the after. This is the only thing in chapter 9 where you have dependent samples. Everything else is assumed to be independent. So because these are dependent samples, none of the regular 2-sample tests work. The 3 2-sample tests under stat and tests assume you have independent samples. So that's why you can't use that. But you can trick your calculator. If you go to the regular t-test like you're in chapter 8, the regular t-test will work on dependent samples if you select your input to be data, and mu0 will be 0 every time. That's what we put in the null. And then the key thing is to get the list to say L3. Normally we leave that as L1 if we're doing other data problems, but the test doesn't have any other data problems. So if you keep yourself on stats for everything else, and then the list should be L3 for this one before and after problem. Don't change the frequency from 1 but I do need to change. I'm currently on not equal to, and I need to set that to greater than. And then calculate. And then I got a p-value of 0.08266, so I'll make that 66 become a 7. The rest you know how to do. And if for some reason you blank out on the test and you can't remember how to do the L3 stuff, make up a p-value and you'll get 2 points off, but then you can get the last 4 points. So alpha's 0.05. Make that 0500. 827 is greater than 500. Now our p-value is greater than alpha. So it's not less, it's not low. The null does not have to go. Do not reject the null. There is not enough evidence to support the claim. So this is saying whatever diet they're putting these dogs on is not working. If they tried to make a commercial and say, buy our dog food or do our diet and your dogs will lose weight, they could get sued for that because this is showing it's not significant. They're not making dogs lose significant amount of weight. Maybe it worked well for one dog, but that's probably because they found a really overweight dog and then it's easier to make that one lose weight. It's not about any one dog, it's about the mean difference. If it doesn't help them all on average, then it's not considered significant. So you get these companies try to get away with stuff like that, but so they're putting some low-calorie filler in the dog food. So then they're trying to claim it's healthy, but maybe it doesn't really do much. That's what this is saying. Okay, so we've done all 7 types of problems that you need to know for the 5 free responses. You can skip number 5, so your maximum grade will be a 90, and then I'll add 10 points. And on the Chapter 8 homework, you can skip 19 and 20, and I'll add 10 points there too, because they're 5 points each. And it'll be after the deadline passes, so you'll see it over the weekend at some point. So you should be all set now to work on any homework problem except 19 and 20 in Chapter 8, any review problem except number 5. And then you can just practice for the test. Make sure you study your quiz for the multiple choice. And try those 7 problems in the review for the free response. We often get a lot of A's and F's on this test because if you know what you're doing, it's not that hard. If you don't know what you're doing, you lose a lot of points over and over again, unfortunately. So this was only an hour and 12 minutes. Now notice I'm going to stop the recording right here. Stop recording. And then lately it hasn't been showing up in the media gallery. So if it doesn't show up in the media gallery, then I'll post this camera video somehow. But that's it. Good luck on the test.